Alright, so for section 11.3, we're going to be looking at surface area and surface area of pyramids and cones. So let's start out with some definitions. First, our objectives. Our objective first is to find the area of a pyramid, and second, find the surface area of a cone. So a pyramid is a polyhedron in which one face, which we call the base, can be any polygon, although we will mostly just work with, squares, rectangles, and triangles, but you can have, pentagons, octagons, whatever, decagons for the base of your pyramid. So it can be any polygon, and then the other faces, the lateral faces of the pyramid, are triangles, and they meet at a common vertex, or a common point, which we call the vertex of the pyramid. So I drew a little picture right here. We've got our base here, which in this case is a square or a rectangle, and that is the base of our pyramid. And then the triangles here that all meet up at this point here are the lateral faces, which I've actually colored in this lateral face in orangish color. And they meet up here at a point called the vertex. So we name a pyramid by the base shape. So for example, this pyramid here, since we've got a rectangle, would be a rectangular pyramid. The altitude of the pyramid is the perpendicular segment. Remember, that's what that little sign right there means, is perpendicular. Perpendicular segment from the vertex to the plane of the base. H, the height, is the length of that altitude. Now, one thing that we talk about for pyramids is what's called the slant height. Slant height, we use a cursive L for slant height, and it's the length of the altitude of the lateral face of a pyramid. So here I've got myself a hexagonal pyramid. My base is a hexagon, and if we drew an altitude on the face of our figure, on the triangle part, then that is our slant height. We're gonna assume that, the slant height is the length of the altitude of the lateral face of the pyramid. Okay, so we will assume that all the pyramids that we're working with are regular pyramids, which means square pyramids, equilateral triangles for the base for a pyramid. I think that's what we're going to be working with, unless otherwise we're going to be working with regular figures. Alright, so our formula for the surface area of a pyramid is surface area equals B plus 1/2 PL. B is the base area, so if we're working with a square, it's just side times side. If we're working with a triangle, it's 1/2 base times height. P is the perimeter of the base, just like we did in prisms, where we had to find the perimeter of our base, and L is the slant height. And then I wrote right here that our lateral area, if we're looking just for lateral area, that's this part of our formula, the 1/2 perimeter times slant height. If you're looking for the entire surface area, then we add that base area on too. Otherwise, you just have the lateral area. So this is our formula for finding the surface area of a pyramid. Alright, example 1. Find the surface area of the given pyramid. Alright, so we've got ourselves a square pyramid. Our base is a square. So for our base area, all we need to do is the side squared. So 12 inches squared is 144 inches squared. And then we're given the slant height is 11 inches. And so all we need to do now is find our perimeter of our base. If we've got a square, they're all the same length, so 12, 12, 12, and 12. So we do 4 times the side length to get our perimeter, which would be 48 inches. And so we're just going to plug that into our formula. Remember, the formula is base area. I'll just write the formula right up here. Base area plus 1/2 perimeter slant height. Okay, so our surface area is 144 inches squared plus 1/2 times the perimeter, which we found was 48 inches, times the slant height, which is 11 inches. Alright, so that's what we're going to plug into our calculator. Let me find my calculator first of all. Okay. So we've got 144 plus 1/2 times 48 times 11. And we get 408. So our surface area is 408 inches squared. If you hear someone talking in the background, that's Connor. Alright. Example 2. Find the lateral area of the pyramid to the nearest whole number. Okay, so the thing with this one is that in our picture, we're given the altitude of our pyramid. We are not given the slant height. So we're going to have to figure out our slant height. But that's not going to be too difficult to do. If we took, oh, and here comes my cat now. If we took our pyramid and took a slice of it, oh, the cat's going to scratch me. No. Okay, got rid of the cat. Alright, so we're gonna, if we took a slice of our pyramid and looked at just the altitude, and then this would be the lateral face of our pyramid, and this would be part of our base. Okay, so we know from our picture that our altitude is 6. We also know, since this is a square, this is 4 meters, and so half of that is going to give us 2 meters for the other part of our triangle. And this is a right triangle, so we can do Pythagorean theorem. So it's going to be 2 squared plus 6 squared, and that's going to give us our slant height squared. So that's 4 plus 36 equals L squared, which is 40. So to the nearest whole number, the square root of 40, oops, delete, square root of 40 to the nearest whole number is 6. So we'll put in 6 for our slant height. Alright. Now base area again. Oh, they just want the lateral area, so we didn't even need to find the face area for this. Lateral area, remember, is 1/2 perimeter times the slant height. So we're just looking for lateral area. So perimeter, though, would be 4 plus 4 plus 4 plus 4. So perimeter is equal to 4 times 4 is 16 meters. Alright, so our lateral area, 1/2 perimeter times the slant height, which we found was about 6. So 1/2 times 16 times 6 is 48. So lateral area is approximately 48 meters squared. Okay, Example 3, we're moving on to a triangular prism, and remember, we're assuming these are regular triangles. So if our base, we've got one side of our base is 6 radical 3, that means every base here is, every edge is 6 radical 3. So it says, find the lateral area of the given pyramid, round your answer to the nearest whole number. Now again, they don't give us the slant height, so we're going to have to calculate it. They already show us that this part's 4 and this part's 3. So we can just set that up into the Pythagorean theorem. 3 squared plus 4 squared is equal to the lateral area, or the slant height squared. So that's 9 plus 16. 25 equals L squared. Square root of each side, and L is equal to 5. Now, perimeter for this, we've got 6 radical 3 3 times, so 3 times 6 radical 3, and that's going to give us 18 radical 3 for our perimeter, and our slant height was 5 inches. Alright, so again, we're just looking for the lateral area this time. We don't have to do the base area formula. So our lateral area, 1/2 perimeter, which was 18 square root 3, times the slant height, which was 5. 1/2 times 18 square root 3 times 5. And rounded to the nearest whole number would be 78. So our lateral area is approximately 78 inches squared. All right, example 4. Find the surface area of the given prism or pyramid. Round your answer to the nearest whole number. All right, so this time we are going to have to find the base area of our figure. So we've got, let's see. Oh, and we need to find our lateral, or our slant height too. All right, so let's start by finding our slant height. We know 5 squared plus 12 squared equals L squared. So that's 25 plus 144 equals L squared. 169. Square root each side, and L is 13. Our perimeter, we know each side is 10 radical 3. So that's going to be 3 times 10 radical 3, which is 30 radical 3. That's feet, and that's feet. Alright, base area. So if we look at just our base area, I'm going to draw myself a triangle over here. We know we're working with regular figures. So this is a 60, an equilateral triangle. This is 60, that's 60, that's 60. And if we drop our altitude, which we need for our formula, we need to do 1/2 base times height. Let's see, this is 10 square root 3. Half of that would be 5 square root 3. So we've got a 30, 60, 90 triangle. We know the base, or the longer leg, I'm sorry, is the shorter leg times the square root of 3. So h is going to be 5 square root of 3 times the square root of 3. So if we plug that into our calculator, times the square root of 3 is 15. So our height is 15. So base area, 1/2. Base is 10 square root of 3. Height is 15. So 1/2 base times height, 75 square roots of 3. And that's our base area. So that was feet squared. Alright, so now we have everything we need to be able to calculate our surface area. So remember, surface area is base area plus 1/2 perimeter times slant height. So we've got 75 square root of 3 plus 1/2 perimeter, which was 30 square root of 3, times the slant height, which was 13. So that is 75 square root of 3 plus 1/2 times 30 square roots of 3 times 13. And I got 267, and it says to the nearest whole number, so we round that up to 268, or 468, I'm sorry, 468. So our surface area is approximately 468 feet squared. Alright, definition of a cone. A cone is a solid that has one base and a vertex that is not in the same plane as the base. However, the base of a cone is a circle. In a right cone, the altitude is a perpendicular segment from the vertex to the center of the base. The height, h, is the length of the altitude. Again, we have a slant height with a cone, just like we did with our pyramids. And the slant height, L, is the distance from the vertex to a point on the edge of the base. And so here we've got a cone. Our base is a circle. Since our altitude goes to the center of our base, we can figure out what our radius is for our base. H is the length of our altitude, and L is the length of basically the surface of your cone. So our surface area formula is surface area of a cone is B, base area, plus pi RL, and that pi RL is our lateral area. Now, we know our base is a circle, so our another way to write this, since we know our base is a circle, we can say pi r squared plus pi RL. So that's another way. I think that's how I work them out in my examples, is this formula right here. But B is the base is pi r squared, R is the radius of the base, and L is the slant height. Example 3. Let's see, let me zoom in a little bit on this. Alright, example 5. What is the surface area of the cone in terms of pi? Alright, so we know we've got our radius is 15 centimeters, and our slant height is 25 centimeters. And that's all we need to plug into our formula. So our surface area is pi r squared plus pi RL. So 15 squared is 225, so 225 pi plus 15 times 25 is 375, so 375 pi, and if you add those together we get 600, so 600 pi, and this is centimeters squared, and that's your surface area. Example 6. The radius of the base of a cone is 16 meters. The slant height is 28 meters. What is the surface area in terms of pi? Alright, so again, we're given all the information we need. We know our radius is 16 meters, and our slant height is 28 meters. Our formula for surface area, pi r squared, so pi 16 squared, plus pi r8, or pi rl, so pi 16 times 28, So 16 squared is 256, I believe. Yes, 256. 256 pi. 16 times 28 is 448. So 448 pi. And if you add those together, you get 704 pi. So our surface area for our cone, 704 pi centimeters squared. What? Alright, sorry about that. My cat attacked my arm. Alright, what is the surface area of the cone? We've got radius of 7 centimeters. We've got a slant height of 10 centimeters. So plug that into your formula. Surface area is pi r squared plus pi r L. Oh, sorry, L, which is 10. Okay, so 7 squared is 49, 49 pi. 7 times 10 is 70, so 70 pi. And 49 plus 70 is going to be 109 pi. And that's centimeters squared. So there's the surface area of your cone. Oh, sorry, is it 119? Let me make sure I did my math right. 49 plus 70. Yeah, it is 119. Excuse me, brain fart. 119. Sorry about that. Okay, example 8. In a chemistry lab experiment, we used the conical filter funnel shown. How much filter paper do we need to line the funnel? Okay, so you'll notice we've got that our diameter is 80 millimeters, so we can figure out our radius real easy. And our height is 45 millimeters. What we're missing is our slant height. So we're going to have to calculate that. So let's start. I'm draw myself a little picture. Excuse my kids yowling in the background. Let's see. This is going to be 40 millimeters. So that's this side. This side is 45. And the hypotenuse is our slant height. So we can write ourselves an equation using the Pythagorean theorem. 40 squared plus 45 squared equals L squared. Alright, so guys! Sorry about my kids. Okay, so 40 squared is 1600. 45 squared is 2025. And that equals L squared. So add those together. 1600 is 3625 is equal to L squared. So to get L by itself, we're going to square root on both sides. And approximately 60.2 is our slant height, 60.2 millimeters. And we know our radius is 40 millimeters. All right, so when we're talking about a filter paper to fit in here, we're not talking about the entire surface area of our cone. We are talking about just the lateral area because we're just on the inside of the cone. So we're looking for just the lateral area, which is 1/2 perimeter, no, not perimeter, that's for a pyramid. 1/2, pi, sorry, pi RL. Alright, so pi times 40 millimeters times 60.2 millimeters. So 40 plus, or times 60.2, 2408 pi. Let's see what that is. Approximately equal to 2408 pi is approximately 7,564.9, so I'll round that up to 65 millimeters. So that's the lateral area of our cone. Example 9, a meditation pyramid is built similar to the Great Pyramid. Find the surface area of the pyramid to the surface area of the pyramid below, rounded to the nearest whole foot. And this pyramid that they're building is the same as these dimensions. So again, we're missing our L. We have a square base, so we know this part right here is 4. So we've got a triangle, right triangle, base 4, height 5. We're looking for the slant height. So that's 5 squared plus 4 squared equals L squared. 25 plus 16, or 25, I think I said 75. 25 plus 16 is 41. And then we're going to take the square root of each side. So our slant height, let's do an approximate solution since we're rounding to the nearest foot. It's approximately 6.4. This is feet. All right, so if we're looking for the surface area of the pyramid, remember that's base height, or base area, which is a square, so 8 feet times 8 feet is our base area. And then we need our perimeter, which is 4 times 8, which is 32 feet. And we got our slant height. So our formula is base area plus 1/2 perimeter times the slant height. So let's plug that into our calculator. 64 plus 1/2 times 32 times 6.4. Round it to the nearest whole number, so 166, approximately 166 feet squared. Last example. Find the lateral area of a snow cone cup with a diameter 3.2 inches and a slant height 4.3 inches.
I am Dr. Connor.
Say hello to Dr. Connor. We've got lateral area, so that's pi RL. Let's see, if D is 3.2, R is going to be 1.6. So R is 1.6 inches. So pi RL. Give our answer in terms of pi. So 1.6 times 4.3 is 6.88. So 6.88 pi. And that's inches squared. And that's your lateral area.